Viewers, this is the video lecture for the subject Theory of Computation, and we are going to see one topic from the second unit, that is proving languages not to be regular. Objectives are to analyze the problems to prove a language is not regular, to understand the concepts of pumping lemma. Now, to prove a language is not regular, pumping lemma theorem is used. Pumping lemma is one problem solving method which is derived from one theorem. Pumping lemma method is to be applied to show that certain languages are not regular, and it should never be used to show a language is regular. If L is regular, it satisfies pumping lemma. If L does not satisfy pumping lemma, it is considered as not regular. Now we are going to see the problems. Show that the language L equal to a power n, b power n greater than or equal to 1 is not regular. And according to our theorem of pumping lemma, we will do the problem with a sequence of steps. In the first step, we will assume the given language is regular. So we will solve the pumping lemma problem with the concept of proof by contradiction. So in the first step, we are considering the given language is regular. And in the second step, we will take one sample string. That is our language is a power n, b power n. We have to take one sample string from our language. So we can take z as one of our string. That is z equal to a power m, b power m be a string from our language. And in the third step, according to the pumping lemma, z equal to uvw. Z is actually, what is z? Z is our string, one of the string. And we will write our string with the help of three variables u, v and w. So we will write a power m, b, actually z is a power m, b power m is equal to u, v, w. This is our equation number 1. Then in the step 4, we will write another one common standard equation from the pumping lemma, that is u v power I w equal to u v dot v power I minus 1 into w. This is one standard equation, that is the equation number 2. Now we are going to derive the values for u, v and w. So u, v, w is nothing but our string. We are going to split our string for getting the values for u, v and w. Now we can, so in the equation number 1, we all know u, v, w is nothing but our string. So u, v means we have to partition our string. One part of our string will be u, v and the remaining part of our string will be w. So we are taking u, v equal to a power b, a power p. So a power p is one portion of our string. And we are considering v equal to a power q. That is a power q is one portion of uv, a power p. Like for example, we can say a power 3 is one part of a power 5. In such a way, we are taking uv equal to a power p, v equal to a power q means a power q is some portion of some part of a power p, and q should be less than p. And now we are going to substitute u, v and v in equation number 1 to get the value for w. We all know u, v, w constitutes our string. Now we can write our example string a power m, b power m is equal to, what is u, v? A power p. Then w, simply we are writing w. Now we are taking the w term in the left hand side. And again when we take the value w will become a power m, b power m divided by a power p. When we solve for a power m minus p dot b power m. So we get the value for w equal to a power m minus p dot b power m. Now we are going to put I equal to 1 equation number 2. Our equation number 2 is this. When we put I equal to 1 in equation number 2, we are getting, our equation number 2 is u, v, I, w equal to u, v into v power I minus 1 into w. So when we get I equal to 1, we are getting uv dot v power 0 w. So when we substitute the value of uv, here we have to substitute the value for uv, v and w. uv is a power p, v is a power q power 0, w is a power m minus p dot b power m. And we have to simplify it. A power p into a power q power 0, it becomes a power 0. A power 0 becomes 1. And the remaining terms. Again we have to simplify it for a. So finally we are getting a power m dot b power m. So this is the string format which belongs to our language. And now we are going to put value I to I in the equation number 2. We have to do the same kind of simplification. We have to write the values for uv separately, v separately and w separately, and we have to simplify it. And finally we are getting a power q plus m into b power m, which is the form which belongs to the format different from our string format. So which is not belong to our language format. So it leads to contradiction that L is regular. Initially we have assumed our language is regular. Since our last string format will not match our language string, our assumption is wrong. That is, L is regular is wrong. So we are concluding that our language is not regular. That is, our language a power n, b power n is not regular. And again we can see one more problem. Show the language is not regular. The language is L equal to a power m. P is a prime number. So in the similar way we have to write the step-by-step manner. Let us assume our language is regular. Then we have to take on sample string as is set. Then we have to write the pumping lemma equation, that is z equal to uvw. So a power m equal to uvw, that is equation number 1. Then decoding pumping lemma, we have to write the another one standard equation, that is uviw equal to uv dot v power I minus 1 into w. This is equation number 2. Then we have to take the individual, we have to split up our string and we have to find out the values for uv separately, v and w. Initially we have to take uv as a power k, v equal to a power j, that is a power j is some portion of a power k. By substituting uv and v in equation number 1, we have to get the value for w. Then we have to put I equal to 1 in equation number 2. So, and we have to simplify it. So uv is a power k, v power 0 means v is a power j power 0. Then we have to apply the value for w. Finally we are getting a power m. By simplifying that, we are getting a power m. So a power m is the string structure which belongs to our language. After that we have to apply I equal to 2 in equation number 2. And we are simplifying by putting the values for uv, v and w. And finally we are getting the string pattern a power j plus m, which is the wrong pattern, which is the pattern which not belongs to our language string pattern. So it leads to contradiction, that is our initial assumption L is regular was wrong. So hence we can tell our language is not regular. So we have to do the problems in this manner. And the possible university questions are: prove for a given language that the language is not regular using the pumping lemma theorem. Thank you.